The sun just came out. We had a bit of morning shower, bit of drizzle. It was wet. Sun comes out again. Perfect weather to fully charge our battery today. Let me show you here. We are on 93% and we are charging with over 3 kilowatts now. We've got almost 60 amps outside, guys. Welcome back to the off-grid garage in sunny hot Australia. And I have prepared all my devices already. We will do a screen recording later on once we are closer to the 100% state of charge, and then compare what is actually going on with 3 parallel battery banks, 16S configuration lithium iron phosphate batteries. We've got the Overkill.Solar BMS, the JK-BMS, and the third battery is connected to a Heltec BMS at the moment. Now we can see here 13 amps into the top battery, and we can see here 12 amps. Here we can see 14 amps, we can see 15 amps, we can see around 13 amps here on the Overkill. 14, 15, it changes constantly. How stupid is that? There's no way I can make a video with that shit. Sun is coming, going all the time. Solar charge controllers must be working hard. So around 10 amps, 9 amps, 11. Well, here our top battery has 54.1 volts, 7 millivolt deviation. We are charging with around 10 amps at the moment. And battery voltages are 3.38. Yep. That's all pretty good. The JK-BMS, 10 amps as well. Deviation is 4 millivolt only. And all the batteries are at 3.38. So perfect. These two are matching fine. And the Heltec BMS only shows us 8.7 amps. And here you can see the difference again. The app shows us 5.8, but we actually charging with 7.2 amps. So the current sensor in the Heltec BMS is completely off, and I haven't heard back from Heltec about the calibration or something, but it is weekend at the moment, so hopefully on Monday we get some good news and we can recalibrate this current sensor here. Anyway, we've got a 9 millivolt deviation across the whole 16 batteries and 3.38 volt as well. So it seems like all 3 battery banks are fairly stable and voltage-wise the same. But as we know, this doesn't mean anything with lithium iron phosphate batteries, right? You can see 8 amps, 8 amps, 4 amps only, which is not correct. I've got my battery internal resistance tester here. Before we fully charge, I want to measure the internal resistance of the whole battery bank as such. And for this purpose, we turn off our top battery bank here with a circuit breaker. So this battery is completely isolated from the rest of the system. And I'm going to measure here on top of the bus bar next to the terminals. 5.66 milliohms. So this was the pure battery from positive to negative terminal across all the terminal and bus bar connections. I want to do a second measurement here on the output or input of the circuit breaker. So we measure including all the cabling and BMS. There we go. That's the second measurement. 8.4 milliohms. Okay, I'm turning on the circuit breaker again and we can see a high inrush current into this battery, hopefully. Maybe not. 20 amps only. Okay. So the battery banks are now equalizing, transferring energy from these 2 battery banks into this one because this was off for a few minutes. But as you can see, it's not too high. Okay, we do the same with the middle battery here. Turn off the circuit breaker. Going to measure the battery directly at the terminals. 7 milliohms. And here as well, second measurement on the output of the circuit breaker, including the BMS, 8.5. Let me do this once again with the bottom battery. Okay, battery is isolated, measuring directly at the terminals. And we've got 6.28 milliohms. And second measurement at the circuit breaker, 8.4 milliohms. So here's the result again. So you can see the top one is a bit lower in internal resistance, but I think this is because this is a larger capacity battery. So the internal resistance usually is a bit lower than with the lower capacity batteries. But we can see this is what the solar charge controller sees. We've got around 8.5 milliohms, and this includes the single BMSs as well. And the overall internal resistance, including the BMS, is what determines the current going into the battery. So we should see fairly equal currents going into the batteries, assuming they are on the same state of charge. And this just shows again the big advantage of having 3 separate battery banks with separate BMSs and separate switches or circuit breakers. We can just turn off one battery bank completely and the whole system runs from the remaining battery banks. I can even turn off 2 of these battery banks and one would be capable of running the whole system with 2 inverters here just fine. So all 3 solar charge controllers are sitting on 55.2 volts, which is my absorption voltage. I have set the absorption time to 8 hours. Well, we are not going to keep the battery on 55.2 for 8 hours, but this is more for the testing we are doing now. I want to keep the 55.2 for an extended period of time now to do some measurement and to see how the balancing works and to see how the overall performance of these 3 batteries is at this voltage then. So the Overkill BMS shows us 79% state of charge, which could be accurate. I'm not 100% sure. The JK-BMS shows us 91% state of charge, which could also be accurate. The Heltec BMS shows us only 54, which I think is far too low. But we will see what is going to happen. I'll be back once we get a bit closer to 3.4 volts over 3.4 volt charging voltage. I have now connected the Renogy 3 kilowatt inverter here to our Basin 300 ampere hour battery, which is around half full. And then the power lead goes to our power supply here or charger, and we charge another 16 amp into the battery now on top of we get from the sun, just to speed things up a little bit. So this is another 830 watts coming from the power supply here. So I've got now these 2 solar charge controllers, this extra solar charge controller, plus a power supply here, all charging these 3 battery banks in parallel. I'm just mentioning this because people have asked if you can do this actually. No problem at all. You can connect as many chargers as you want as long as you are staying in the specifications of your battery. So, and basically only the battery in the middle is fully top balanced because I have used this for quite a while now. Neither the bottom nor the top battery is calibrated, balanced. Basically I have just connected all the single cells as they have been delivered. And we can see very clearly again that the voltage of these cells is not rising. Even we are pumping energy into this battery for hours and hours, days. The voltage is not rising much. So we are still in the flat area of the curve. And with lithium iron phosphate batteries, the voltage will only rise once the battery is almost full. If you see voltage rising over 3.4 volts, you are at 97% already. And here we can nicely see once we have a cloud and the current actually goes down, the voltage drops as well. So the single cells are not holding the voltage. That means they are not saturated, and we are still a bit away from 100% state of charge. Yeah, guys, that was it with solar today. Thick clouds. It just started raining again a couple of minutes ago. We basically have 11 amps, 10 amps outside at the moment. There's nothing coming in. It can take another day until we actually hit the 100%. Because this is not accurate. So what we are going to do, pushing another 16 amp into our system. Now we've got 26 amps. Here's also something different I noticed with the Heltec BMS. If I turn off charging, right? So we go back and it shows us 0 amps here. You can still see 14.9 here on the display, right? But 0 on the app. So if I measure that, We have actually 0. But the display is still 14.9 amps. And then after a while, charging turns on itself again. Just watch. There it goes. Charging has just turned on again. Why is this happening? That is totally unreliable. We are charging with 23 amps again. Why is this happening? That is not good. Charging disconnect. Are you sure? Successful setup. Yeah, now it's turned off for a while. But after 30 seconds, 40 seconds, it turns back on again. For no particular reason. I'm not touching anything here. I'm not touching the display, nothing. 0 amps at the moment. And then it starts charging again. That is not good at all. It is already 4:45 and we are still charging. The sun has gone down behind clouds now, and I'm not expecting to get the battery full today. I've got the power supply running. Depleted all my batteries here so far. Everything went into this battery, but we are still charging. I think this battery is almost full. It shows 99% state of charge and 279.8 ampere hours. Yeah, so very close to 280. And you can see it's only taking 1.8, 1.5, 2 amps sometimes, while the other 2 batteries are still charging with a higher current. And if I turn down the current to 5, for example, it actually stops charging here, while the other ones are still charging. So I think these batteries are already saturated now, and the voltage is just going up and down with the other batteries now. And as soon as these ones are rising as well, this one is already completely full and will not take any current anymore. And then we will see the Overkill and the Overkill and the Heltec battery are taking all the power. But I guess this will be tomorrow then. I've got no power anymore and I don't want to connect the power supply to the grid actually. This will be pure 100% solar power. I've got all my solar panels on the driveway, cables everywhere, recharging these batteries at the same time as, well, okay, I would say you have a good night's sleep and we see us tomorrow morning. I have turned off the power supply here and now we can see the JK battery is actually being discharged. So this one charges now the other 2 batteries. It again shows that this one is already fully charged and is just waiting for the other ones to catch up. So I'm not expecting that there will be much power going into this battery tomorrow. Mainly we are charging this battery and this battery then tomorrow. And this will be a race between Overkill and Heltec, and I think the Overkill will win again because the state of charge is higher. And then once this is full as well, all the power will go into the Heltec BMS or battery. So hopefully tomorrow, guys, hopefully tomorrow. Good morning and welcome back to the same video. And this morning, well, what can I say? When I do battery testing and I'm reliant on solar energy, it looks like this. You know, we've got clouds and it is even raining. I can't see that we are fully charging this battery today. But anyway, I've got the Overkill battery here and the JK battery and the Heltec battery. And we can see the Overkill still pulls 7.4 amps. The Heltec BMS 4.5, which we know is about 20% too low. And the JK-BMS 0.9. So that means that this battery is really charged at 3.38 volts. Saturated, absorbed. So the battery cells will not take any energy anymore at this voltage. The battery obviously is trying to raise the voltage now because there's still power coming in, but it can't because it's paralleled with these 2 laggards here and needs to wait until they catch up. And once they are catching up and the voltage slowly rises, and this battery will take energy again because then the voltage in the cells is rising and there's space for more energy. But at the moment, 0.5 amps, I've seen even 0 there. And all the energy is now going into these 2. And eventually they will be all the same state of charge. Because at the moment we've got the same voltage, but as you can see, state of charge is obviously different. This one is almost at 100%, this one is probably at 90, I hope, and this one maybe at 80 or something. But as you can see, there's no problem to parallel battery banks if they have their own BMS, even with different state of charges. It doesn't matter. They balance themselves out. Okay, so to get more energy flowing here, what do we have? 13 amps outside, 11, 10. Well, to get more energy flowing, I was thinking of reconnecting the old battery here, which still has around 40% of capacity left. And we can use one of the boost converters actually we have and slightly increase the voltage of this battery, maybe only on 2-3 volts or something. And this will give us a 20 amp charge into our big battery here. And then we can discharge this battery with 20 amps and put the energy back into this battery. They have an over 90% efficiency, so it would be a good usage of this energy here. The alternative would be to hook up the Xia inverter and then use our power supply here and charge the battery with 20 amps again. But because of the losses in here and the losses in the inverter, we will pull a lot more energy from the battery. So I think the solution with a boost converter is the most efficient. And we need more energy here, otherwise it will take another 6 weeks or something until this battery is fully charged. See, now we've got the situation here. 6 amp into this battery, 6 amp into this battery, and 0 in the JK. Doesn't take any energy anymore. Just waiting. Just waiting. Yep, that's the boost converter. And I'm just checking the specs here. It says input voltage 8 to 60 volt DC and output is 12 to 80 volt. So that should actually work. So we've got the 53.5 volts input on the booster, and I set up the output to 56.6. So it works. I'm just testing this before I connect it to the big battery. Okay, let's get this battery over here and connect this all together. Okay guys, I've got the old battery hooked up to the new battery and it's charging with the boost converter. So positive, negative going into the boost converter here around 53 volts, and we're getting 56 or 55 volts out of here. And well, we are pulling 12.5 amps from the old battery, and we are pushing 11.5 into the new battery. So that's pretty good. It's only 1 amp missing in the conversion. I think I have to use a fan here very soon, but I want to actually increase the current. So if I turn this one clockwise, yes, yes, 15 amp, and we can see 11 amps. Yeah, we should see it here. 850 watts coming from the old battery now. Yeah, I've just connected to the QUCC BMS here in the old battery, and we are pulling 18 amps from this old lady. Nice, it still works. So if I turn off charging here on the BMS, we should actually see the current going to 0 here on the amp meter. Yep, it beeps. Yep, everything goes to 0. Okay, we turn it back on. Oh! And the magic smoke! It didn't like that. Holy frickin' look at this! Woohoo! So, okay, that was the okay, let's turn this battery off here for a moment and have a look at the damage, see what's going on. So I have replaced both fuses now. They are both toast. And I connected my power supply now, 53 volts. And when I connect the positive here, we're getting a short. See, the voltage goes down and 0.2 amps going into the PCB. Definitely a short somewhere. Could be the input MOSFET down here, but I haven't got any spare parts to repair that. So I guess at the moment, trim it, because this one is faulty as well here for some reason. And now I've got two faulty ones. Alright, the good old Xia. Usually running our dishwasher or washing machine or any other appliances in the house, but now it is charging the other battery. Oh. There we go. So we are now at over 3.4 volts of charging voltage per cell, 54.5 volts, charging the top battery with the Overkill.Solar BMS with 25 amps, charging the bottom battery with the Heltec BMS with about 18 amps, and almost nothing goes in the JK-BMS at this point of time. 4.4 volts I can see. At 4.45 the balancer will kick in as well. 35 millivolt, 30 millivolt and 33 millivolt deviation. See, and now the voltage is slowly rising in this battery as well as the other ones are catching up, and we can see a tiny current going in to saturate the cells at this new voltage now, while the other ones take full advantage of the power coming in because the cells are not saturated yet. And this one is at 0 at the moment. I leave charge balance turned on as it is per default, and let's see what's happening. Because cell number 11 is already at 3.61 volts and we are still charging with 13 amps. So I guess the BMS will disconnect the whole battery at any point of time. So it's balancing number 10 and number 11 at the moment, because they are over 3.45 volts. But the passive balance current is only 150 milliamp. So this goes off the 12.2 amps. For these two cells. 3.64. We should see that the charge button turning off at 3.65. There's a bit of a delay depending on the settings. We're over 3.6. Yeah, it has turned off the whole battery bank now. 0 amps going in. And oh, look at this. This one is actually balancing here. Even the charging is off. That's a different JBD BMS here. That is how it's supposed to be. It should balance all the time. Not only while charging or while discharging, but all the time. So that is great. So 0 amps in here, 4.7, 5 amps into the JK, and about 18 amps going into the Heltec battery at the bottom. This one claims 75% and now it claims 100. What's going on here? Same situation here. One battery cell is high and has turned off the whole battery. See, the charge state is off and now it turns it back on. Yeah, it's cell number 14, 3.58. Bang, again. What's the setting for it? Over voltage. Okay, 3650 we can go. And now we can see a little flash symbol in there, which means the balancer is on for this one cell. But this one has only 120 milliamp passive balancing as well. So it will discharge this one cell with 120 milliamps now until a certain threshold, and then it turns on the charging process again. I'm not sure what the difference is until the battery turns back on, because you cannot see or cannot adjust this parameter in the settings. And obviously it will continue doing this cycle now until all the other cells have caught up. And now it claims we are at 100%, but this is only this one cell which is at 100%. All the other ones are still a bit lower. And we can see the same situation here with the Overkill battery. 3.4 6.5, then the charger turns off, it gets discharged with a balancer, and now all the current goes into the JK-BMS. So we can finally start the screen recording here. We have got charged all 3 battery banks now. So on the left we've got the Overkill BMS with the top battery. In the middle we have the JK-BMS with the battery in the middle shelf, and at the right we've got the Heltec BMS with the battery in the bottom shelf. Whew. And the Overkill and the Heltec BMS are turned off, as you can see, because we have an overvoltage situation with one of the cells. At least the Overkill gets balanced, but I'm glad the balance function actually works here, even there's no charge current going into the BMS. Well, I'm not sure what's happening with the Heltec BMS here on the right, because the current is turned off. Let's have a quick look here in the settings again. Yeah, 3.65 volt, it turns off, but there is no recovery voltage which can be set in the settings here, which is a bit sad. So at the moment we have 2 of the 3 batteries turned off because of this overvoltage situation of one of the cells, and only the battery in the middle, the JK-BMS, is still turned on and working. But of course it doesn't take any energy anymore at 55.2 volts. So it is shut off. It is balancing as well. 12 millivolt there. 166 on the top battery. That's a lot. And 76 in the bottom where the Heltec BMS is connected to. Charge full, it says. How does it determine the battery is full? And then turns off charging. That is not good. It should not turn off the charging. It should leave it connected and let the charger actually control that, not the BMS. Yeah, and the Heltec BMS is just sitting there now with 70 millivolt deviation, and it doesn't seem to do anything at this point of time. The voltage is slowly dropping down to 53.7. Once the charge function turns back on this BMS, we will have a huge current going into this battery. See, when I click on the More button down here, it says charge full and is red, and this is potentially the reason why the charge state is turned off. But this should not be up to the BMS to decide when the battery is fully charged. Let's see if we can turn it on manually. Charge on. Are you sure? Yes. Is it turned on? No, it's not. Oh yeah, it's turned on now. See, 50 amps. And you can see the JK-BMS is actually delivering energy into this battery, and still no balancing in the Heltec BMS. 3.45 should be the balance turn on voltage, which is cell number 14, but no balance function at all. 35 amps into the battery still. And voltage is rising in cell number 14. There we go, the balance is on. 3.64, 3.668, 3.685. There are 2 more cells balancing, and now the charge button is turned off. Charge function is turned off. Balancing is still on for these 3 cells. I'm not sure why it balanced actually in number 6 and 7. Oh, these are turned off now. The whole balancer has stopped now again. There's the balancer again. 3.6 volts. It's trying to balance this one cell. This one here. And we've got 110 milliamps balance current. Now it has turned off. Now it's back on. So around 100 milliamp balance current, if this symbol appears on the battery symbol. There it is. It's balancing cell number 14 now with 100 milliamps. Okay, that is not too great. This will take forever. So there's basically no current going into any of the batteries anymore. The JK still pulls about 1.5 amps sometimes, but sometimes it goes to 0. And we have now fully charged all of our batteries. I'm not sure about the bottom battery actually, if this is really fully charged. We've got 209 millivolt deviation in this battery. See, and even the Overkill.Solar BMS is struggling, 170 millivolt deviation across these cells. And cell number 14 is still low with 3.348 volts. And it will take a long time until this one is catching up. So it will play this game here for a long time. So even for the Heltec BMS and the Overkill.Solar BMS, I would definitely recommend to install an active balancer, because the balance function, as we see, is not sufficient for these large capacity cells here. Absolutely not. Well, have a look at the JK-BMS. We have 2 millivolt deviation here. It has everything is balanced out. All the cells are perfectly balanced. It has a 2 amp active balancer. So the JK-BMS still stands out across all the other BMSs I have ever tested. I have now connected a 16S balancer to the Overkill BMS here at the top shelf. And we can see cell number, 11? Yeah, 11 gets discharged or balanced with 1 amp. And this energy obviously gets then transferred into a cell with a lower voltage. So it's not wasted. And the active balancer works now in conjunction with the BMS's balancer. So you can connect as many balancers as you like. I mean, if you are really desperate and have no time to spare. So, and now we can see here cell number 11 gets discharged fairly quickly. And we should also see cell number 14, the voltage rising. Because all this energy from these higher cells gets now dumped into number 14 to raise it up. See how quickly it goes down. So we're starting with around 260 millivolt deviation here. And I have installed a second active balancer here at the Heltec BMS. Took me 5 minutes with this twin terminal block. That was an amazing idea. So here on the Heltec BMS I have started with 79 millivolt deviation. I've written everything down. And here with 260 we are down to 218, 17, 16. And then we will see what the actual active balancers have done. Well guys, this is all part of the top balancing process now. You can parallel all your cells at the beginning and charge them all up to 3.6 volts and then put all the cells in series to build your actual battery. Or you can just connect all the batteries in series right away and then connect your BMS in combination with an active balancer and let them do the work for you. Observation here on the Heltec BMS. It turns off charging because it says the battery is full. But I mean, we are at 3.3 volts. Only cell number 14 is sometimes peaking to 3.6. And then it turns off the whole process, not with an over voltage alarm, but with charge full. So I'm not sure how it determines the battery is actually full. As you can see, I have increased the capacity to 300 ampere hours now from 280. Maybe it's counting ampere hours, but it's not doing this either. And as we have seen, there's nothing in the settings which actually describes when the battery is full. And I can turn on charging manually again, which it does. See, it's charging now, but it still sits on 100%. And you can see the voltages here. It's only number 14, 3.5, and all the other ones are 3.4 and even lower. 200 millivolt deviation. Yeah, 3.6. Keeps going. It still says charge full, but it's still charging. There it turns off. 3.62 volts or something it was, and then it turns it off. But this is not the trigger point. There's something else going on. which I haven't discovered, and it says the battery is full and it turns off charging. And there's still a lot of space, so I cannot really fully charge this battery. It doesn't allow me, it turns off charging all the time. This is a really bad feature with this BMS. Well guys, finally, after around 5 hours, I left the battery here sitting on around 58 volts for 5 hours now. Had the active balancers connected to all, well, the JK-BMS has its own active balancer, so. And the Overkill BMS on the left started with 260 millivolt and it's now down to 15 millivolt only. So the balancer has done a fantastic job there. And the Hangsor BMS showed a deviation of 79 millivolt and we are down to 9, under 10 millivolt deviation. Fantastic. The JK-BMS in the middle has the balancer even turned off because we are under 5 millivolt deviation. So I would consider this battery now as top balanced. That is all good. And I think we can now fully put it on TUD. We are on 100% on all BMSs. The Smart Shunt sits on 100%. Everything is good to go. So I would say that's it. Okay guys, so far this very long video from today. I apologize for that, but there is so much to explore, so much to show and so much to share. It is unbelievable. I could make a 24-hour live stream out of that. No problem at all. Show you all the bits and pieces of each BMS all the time. Commenting, exploring and explaining. Yeah, so as you have seen, this is another method how you can top balance your batteries. I have not touched them. They were just sitting on the floor there all the time. I connected them in series and put them in the battery shelf here. Started charging them and then let the BMS and the active balancer, of course, sort it out. The only thing you need for this is patience, because the balancing can take quite a lot of time. So what you can do is you can leave your power supply running overnight, set this one to 3.6 volts or something, and then let the BMS and the balancer sort it out. And in the morning, everything will be nicely balanced. But of course, the usual method is to put all the batteries in parallel first, charge them up to 3.6 volts, and then put them in series. So you don't need to do this procedure anymore here. Well, this is just what I did for the last 5 days, basically. Well, most of it was waiting for the battery to fully charge. So the actual top balance of all 3 batteries took now around 5 to 6 hours. 0 amps, 0 amps, 0 amps. And this is just our standby load and the light here in the garage. So I guess we are absolutely 100% fully charged now and have 44 kilowatt hours of capacity available. So I will turn all my loads now, pool pumps and everything again after 5 days of charging this battery up now. And we will see how the battery performs over the next couple of days. I'm very keen to see how they play together and balance themselves out under different load conditions. Guys, thank you so much for watching. Thanks for all your support here on the channel. Everything you're doing. Especially thank you for all your hundreds of emails I'm getting. That is totally insane. I'm unable to respond to all of these emails, so please don't get mad at me. But emails taking a long time. I'm getting around 25 emails a week now. So please leave all your comments under the videos where everyone can see it and where everyone can chip in, help out to reply, explain things to others and share your own thoughts. Please do not send me emails. I won't be able to reply. And guys, until the next video. Yeah, you stay charged and safe. And thanks so much for watching. See you then. Bye bye.